In the 1970s, Taiwan was falling behind. Taiwan had relied on cheap, labor-intensive manufacturing, things like umbrellas, textiles, and basic electronics assembly. It provided jobs, but it didn't create wealth. The Taiwanese government understood that low-cost manufacturing would never make Taiwan rich fast enough, so it pivoted away from labor toward high-end manufacturing, chips. If it could produce them, it would leapfrog into an advanced industrial economy. That bet led to the creation of TSMC. Taiwan Semiconductor Manufacturing Company makes the most advanced chips for Apple, Tesla, NVIDIA, AMD, Amazon. You can't understand TSMC without understanding the man who built it, Morris Chang. He spent decades inside the American semiconductor industry and helped build Texas Instruments into a powerhouse. He believed, at one point, that he would become its CEO. That never happened. But that disappointment defined his career, because leaving Texas Instruments forced him to build something of his own that would come to change the world. To understand how he was chosen to lead the most important company on Earth, we have to go back to the beginning. Morris Chang was born in 1931 when China was on the brink of catastrophe. Imperial Japan was invading, and civil war was tearing China apart from the inside. War would shape the way he understood survival and competition. By the time he turned 18, Chang had changed schools 10 times. At one point, his father worked as a bank manager in Guangzhou, but when Japan began bombing the city, the family fled to British Hong Kong, a rare pocket of calm and order. That is, until Japan attacked Hong Kong, and nowhere was safe. In 1942, his family decided to escape across the front lines to reach unoccupied China, a journey lasting more than 50 days, with Japanese shelling a constant fear, which Chang would later call the most significant experience of his life. Eventually, they reached Chongqing, the wartime capital of Free China. He attended an elite boarding school, Nankai Secondary School. Despite not having any political or family connections, he was admitted on merit alone. He dreamed of becoming an author, but his father shut that down immediately, telling him, as Chang recalled in his autobiography, "You'll go hungry." His father believed engineering was the future. When Japan surrendered in 1945, Chongqing erupted in celebration. But the peace didn't last. There was continued internal conflict, a brutal civil war between the communists and the nationalist government, the Kuomintang. It was clear Chang had no future in China, and once again the family fled to Hong Kong. It was there that Chang began looking toward a future abroad. An uncle who was a professor at a university in Boston urged him to apply to Harvard. He was accepted, and in 1948, he boarded a plane for the long journey to the United States. He wrote in his diary, "I have never been so far from home, nor ever planned to be away so long. The future is shrouded in uncertainty. How can I not feel sorrow?" In America, Chang was struck by something new: freedom, democracy, the belief that effort could actually change your fate. In his words, as long as you work hard, you can succeed. He thrived at Harvard, doing especially well in physics and mathematics. He also excelled in English, despite struggling with Homer at first, and eventually began thinking in his new language. In 1949, the People's Republic of China was founded. The communists now ruled the mainland. Returning home was no longer realistic. For a Chinese immigrant like himself, engineering became his practical path forward, so he transferred to MIT to specialize in mechanical engineering. His parents could only afford 1 year of tuition, so he supported himself with a scholarship, doing calculation work for professors and typing jobs to make ends meet. Though his father earned an MBA at Columbia at 47, he didn't become successful and scraped by running a small shop. All of his parents' unfulfilled hopes were pinned on their only child. After completing a bachelor's degree, getting married, and finishing his master's, he set his sights on what many Chinese immigrants saw as the path towards a secure future, a doctorate. But the qualifying exam broke him. When he failed the first time, he was still confident he could pass, but he failed on his second try as well. He recalled, "This was the greatest blow of my life. My self-confidence evaporated in an instant." But what seemed like a crushing disappointment at the time turned out to be the greatest blessing of his life. Had he succeeded, he would have been locked into academia, and he would never have touched semiconductors. He'd look back on his failure with a different perspective, calling it the greatest stroke of luck in my life. Instead of a doctorate, he entered the workforce. Within 2 months, he had 4 offers. The first was in a machine tool manufacturer, but the salary was too low. The second came from the industrial firm Metals and Controls, but he found the president authoritarian. The third was a research and development role with the Ford Motor Company. And then there was a fourth. An electronics company called Sylvania had just created a new laboratory dedicated to something Chang had never heard of: transistors. A transistor is the basic building block of every microchip. It's a microscopic, electrically controlled switch that turns a current on or off. Each transistor is 10,000 to 20,000 times thinner than a strand of human hair. Billions of them fit onto one computer chip. These are among the most difficult things human beings have ever manufactured. The world is built by people who understand how things work deeply. If you'd like to sharpen your math, science, and computer science skills to solve harder problems at work or in life, Brilliant is a great place to start, and you can try it for free. Even a single speck of dust landing on a transistor can destroy an entire chip. That's why semiconductor factories, or fabs, short for fabrication plants, look more like clean rooms, with workers covered head to toe, protecting the chip from the outside world. Chang initially leaned toward choosing Ford. It was stable, prestigious, and safe. But Ford offered him $1 less per month than Sylvania, $479 instead of $480. When he called to negotiate, Ford's recruiter shut him down. "We do not haggle. The company has decided on your salary. If you want to join, come. If not, then farewell." Chang didn't like that response and chose Sylvania instead, a life-altering decision over $1. Chang began teaching himself everything about semiconductors. Every night, he worked through William Shockley's Electrons and Holes in Semiconductors, a book he found brutally difficult. He read just 2 pages a night, determined to understand everything completely, with no shortcuts. Semiconductors demanded the same mindset, not speed, but discipline. At Sylvania, Chang worked on germanium transistors, an easier material to process than silicon, but fundamentally inferior. Almost the entire industry used germanium, except for a small company in Dallas, Texas Instruments. TI was already mass-producing silicon transistors, a far more powerful material that most companies believed was too difficult to manufacture. Chang eventually rose to head a research and development group at Sylvania, but he could see the company was falling behind. He never forgot the words of the general manager of the semiconductor division. "Our trouble at Sylvania is that we cannot make what we can sell, and we cannot sell what we can make." From then on, Chang tried to stay away from that trap. When an opportunity appeared at Texas Instruments, Chang didn't hesitate. He joined TI in 1958 and was impressed by the young, ambitious, and intensely driven engineers, most of them under 40. Chang was quickly entrusted with one of the hardest problems: improving transistor quality. His job was to increase yield, the most important metric in chip making. Yield measures how many usable chips survive manufacturing. Improve yield, and costs fall. Chang succeeded and built a reputation as someone who deeply understood manufacturing. When it became clear that a PhD was the next rung up the ladder, Texas Instruments sent him to Stanford. After returning 3 years later, he was promoted again, and his career rose steadily. By the late 1970s, however, something had changed. Texas Instruments was shifting its focus toward calculators, digital watches, and consumer electronics. Chang's passion had always been semiconductors, and the road ahead was narrowing. After 25 years at TI, he realized there was no realistic path to becoming CEO. So he quit, without another job lined up. He was 52 years old. Chang briefly worked as COO of the electronics manufacturer General Instrument in New York and lived in Trump Tower. But the work didn't appeal to him, as the company focused mainly on acquisitions and mergers. What did matter during that period was someone he met, an entrepreneur with a radical idea. That entrepreneur later started a company that would design chips but not manufacture them, something unheard of at the time. Chip companies were expected to do both, but Chang understood that design and manufacturing were becoming completely different problems, and manufacturing was getting so expensive that most companies wouldn't be able to afford the factories. This realization would soon change the world. By then, Chang was regarded as a world-class chip expert and caught the attention of Taiwan, which was trying to leap from low-cost manufacturing into a high-tech economy. In 1973, the Taiwanese government established ITRI, a research institute to learn advanced manufacturing and build a domestic semiconductor industry. Chang became head of the institute in 1985. Moving to Asia appealed to him. Years earlier at Texas Instruments, Chang had seen the region's potential. TI's factory in Japan achieved nearly double the yield of its factory in Texas. When Chang investigated why, he discovered turnover was dramatically lower and technicians were better qualified. In the U.S., he learned that the top candidate for a supervisor role at an American plant held a degree in French literature with no engineering background. Chang realized the future of advanced manufacturing wasn't in the United States, it was in Asia. He proposed a radical idea, a factory that wouldn't design its own chips at all, but would only manufacture chips for others, focusing purely on production. Li Kuo-ting, the economist and politician known as the godfather of Taiwan's tech industry, asked Chang to make the idea commercially viable. In 1987, Morris Chang founded TSMC. He aimed to take on giants like Intel and Samsung, companies that still designed and manufactured chips under one roof. That competitive streak was shaped by growing up during wartime. Chang often compared TSMC's battles with competitors to the battles of World War II. TSMC even secured Intel as its first major American customer. Years later, another important client arrived, Jensen Huang, who had co-founded NVIDIA at age 30. Unable to reach Chang by phone, Huang sent a letter asking whether TSMC would manufacture his chips. Chang called him back, liked the young man, and agreed. NVIDIA's first two successful chips, Riva 128 and Riva TNT, were made by TSMC. With TSMC's manufacturing, NVIDIA has become the leading designer of chips for artificial intelligence. What began as a business relationship turned into a mentorship. In Chang's Taipei office hangs a framed comic from Jensen Huang reading, "Your career is a masterpiece, a Beethoven's Ninth Symphony. Working with you has been one of the great joys of my career." Today, TSMC produces over 90% of the world's most advanced chips. Chang served as CEO from its founding in 1987 until 2005. When the next CEO struggled, Chang returned in 2009 at age 78 to steady the company. He finally retired in 2018. TSMC's market capitalization now hovers around $1 trillion, making it one of the most valuable and arguably most important companies in the world. From Apple's M-series chips to Tesla's full self-driving chips, TSMC manufactures the components that power modern life. Governments now treat semiconductor manufacturing as a matter of national security. The The United States has begun pouring billions into domestic chip making, with TSMC building multiple factories in Arizona. While this is a major step, TSMC's most advanced chips are still manufactured in Taiwan, though U.S. fabs aim to catch up. Morris Chang didn't just build a company, he built a platform the world can't do without. Thanks for watching Econ Trail.